this example, I'm going to show you how to prove the statement using the principle of mathematical induction that's true for all natural numbers n. So here we have a statement S sub n, which is 5 plus 11 plus 17, and then plus 6n minus 1 equal to this. And I'm going to show that this is true for all natural number n. So I'm using the step of using the principle of mathematical induction. So step 1, I need to show that S sub 1 is true. S sub 1 is the sum of the first one terms. So I'm going to do is, we know that the first term is 5. So I need to show that S sub 1 is 5. So I put 1 inside this formula. It's true for all n. I put a 1 in there and I'm going to simplify. So I'm going to have 1 times 3 plus 2, which is 5 times 1 is 5. So everything is equal to 5. So step 1 is, S sub 1 is true for the first term. Then the second step, I'm going to assume that this statement is true for some number k. Okay, so by doing that, I assume that this is true. So I put the k inside the end. So I assume that this is true for some number k. Okay, and then we need to show that the statement S sub k sub 1 is true. So now S sub k plus 1 will equal to 5 plus 11 plus 17 Well, we need to show that if S sub k is true, then the next one has to be true. So then I go up to plus 6 of k minus 1. Then I do one more step. Is 6 times k plus 1 and minus 1. Okay, so this I assume that this is true for some k, then I have to assume that the next step should be true for some natural k. So I now equal to, the formula will be k plus 1. I replaced k plus 1 inside here. I think I will run out of space. I'm try to squeeze what I can. Okay, it's good. So our goal is try to prove that this whole thing here equal to this whole thing there. Alright. Let's see how we do. Now, so our goal is, let me write down. I need to prove that this whole thing here has to be equal to this whole thing there. Don't get scared. It's actually very easy. We claim that, we assume that this statement from here to here is S sub k is true. So I can replace this whole thing as the formula k times 3k plus 2. So I will replace that. So I have k times k times 3k plus 2 plus this guy, which is 6k plus 1 minus 1 equal to k plus 1 times this. This is quite a clever way because I already assume that this is true for all k, and I know that this guy and this guy is the same, which is its formula is that. So I replace this whole thing by S sub k, which is k times 3k plus 2. And I plus the rest, which is my next term. So now I'm going to just simplify using algebra. So I'm going to time this. I have 3k squared plus 2k plus 6k plus 6 minus 1. Like that. Okay, over here, I have to prove this equal to that. So I'm going to simplify, make sure they're equal. So I have k plus 1 times inside here, I can have 3k plus 3 plus 2. So I have k plus 1 times 3k plus 5. So right here, continue to simplify on the left hand side. I will have it's at 8k, then minus plus 5. Take 6 minus 1 plus 5. Now, on the left hand side, we have 3k squared plus 8k plus 5. Right here, I'm going to simplify more. On the right hand side, I'm going to simplify by 4. I have 3k squared. And then I have 5k, I have plus 3k, and then I plus 5k. Then I'm going to simplify the right hand side of my equation. 5k plus 3k is 8k, then plus 5. On the left hand side also the same. Since the left hand side and the right hand side of the equation is equal to each other, that means this statement is true for S sub k is plus 1. Okay, so the statement S sub k plus 1 is true, therefore it has to be true for all natural n. So that is how we conclude this, because it is true for all k and it's true for next step, so it has to be true for another step. By the step of induction, we say that this statement is true for all natural n.